Next topic is reaction quotient, Q, and LeChatelier's principle. So reaction quotient is used to determine if a system is at equilibrium. So for the expression, it will look same as the Kc expression. So concentration of products goes to the numerator and concentration of reactants go to the denominator. But they are the concentration at a particular time, not when the reaction is at equilibrium. So it is used to determine if the reaction is at equilibrium or not. And if Q is greater than Kq, it means there are too many products. And that is because from this expression, if Q is large, then it means that numerator is larger. So it means that there are too many products. And because there are too many products, reaction will proceed to the left to remove the products. So equilibrium will shift to left to remove products. If Q is equal to Kq, it means that the reaction is at equilibrium. If Q is less than Kq, it means denominator is larger. So it means that there are too many reactants. So reaction will proceed to the right to remove the reactants and produce more products. Next is the LeChatelier's principle. And this is a very important concept you have to make sure you know for this unit. And it is quite easy if you understand. When a system at equilibrium is subjected to a stress, the Q value changes and equilibrium will shift in order to reduce the stress. So there are three variables that are considered the stress, which are pressure, temperature, and concentrations. So for pressure, if pressure is increased, then it means the volume is decreased. Then the molecules will be squished together and there will not be space for more molecules. So they will want to remove some molecules so they will not have to be stressed. So equilibrium will shift to the side with fewer moles of gas, so it will produce fewer moles of gas than before to reach an equilibrium. However, if pressure is decreased, then it means that volume will increase and molecules will have much more space. Then the system will feel like they can make more moles of gas, so it would shift to the side with more moles of gas, so they would produce more molecules and then it will reach a new equilibrium. Next variable is the temperature, and it is the only thing that changes the Keq. So in endothermic reaction, heat is considered as a reactant, so it goes to a reactant side. And if temperature is increased, then it means that heat is increased. So because heat is increased, the forward rate will increase and reaction will shift toward the product to remove the heat. However, if temperature is lowered, then it means that heat is removed and then the reaction will shift toward the reactants to produce more heat. And it will be opposite for the exothermic reaction. The last variable is the concentration of reactants. If the concentration of one of the species is increased, equilibrium will shift in the direction that will reduce the concentration of that species. So LeChatelier's principle is all about the stress getting applied and then the system shifting its equilibrium to remove that stress. So for this reaction, which is ammonia synthesis, when N2 is increased, so reactant is increased, equilibrium will shift toward the product to remove the N2 that is added. The product, ammonia, is increasing, but the reactants N2 and H2 from this point where N2 was added are decreasing because reaction is shifting toward products. However, if N2 is decreased, equilibrium will shift toward the reactant to make more of the reactants that was removed. So we see that both of the reactants are increasing because equilibrium shifted toward the reactants and the product ammonia is decreasing. Next is the manipulating Keq and Kp. So there are three main rules: reciprocal rule, multiple equilibria rule, and coefficient rule. So reciprocal rule is when a reaction is reversed, the new Keq value is the inverse of old Keq value. So for this reaction, A plus B becoming 2D, the Kc will be D squared over A times B. But if the reaction is reversed, 2D is becoming A and B, the Kc will be the inverse of this old Kc value, so denominator and numerator will just swap its place and it will be A times B over T squared. And next rule is the multiple equilibria rule, and it is used when two reactions are combined to produce the overall reaction. So Kc for the first reaction equals D6 over A2B, when Kc for the second reaction equals A2F over E3B. So for the Kc of the overall reaction, it will just be the product of these two Kc expressions, which will be D6F over E3 and B2, sum of these B2, and A2 will simply just cancel each other out. So Kc for the third reaction, the overall reaction, will be the product of Kc1 and Kc2. The last rule is the coefficient rule, which is used when the entire reaction is multiplied by a factor. So in this case, the factor was 1/2. So all of these species was multiplied by 1/2. And then the way Kc changes will be that this factor that the reaction was multiplied by will go to the exponent of the Kc. If it was multiplied by 2, the new equation would be this, or C. The new Kc value will be the old Kc value squared, because the factor is going to the exponent of the Kc value. This is the end of the video, and we'll continue in the next lecture.